Here we go, guys. Worksheet 841. Step 1, number 1, what do I do?
Negative.
Factor means GCF and what?
Over to the negative binomial.
Put it into two binomials. So do I have a GCF here?
X. 2.
7x squared. If I pull out a 7x squared out of 14x to the fifth, I'm left with 2x cubed. 7x squared out of 35x cubed? 5x. 7x squared out of negative 21x squared gives me
3.
minus 3 all over 7x squared.
7x squared could cancel.
Now, we're going to do our restrictions.
Of course you can. On my bird.
Domain, 7x squared cannot be 0, which means x squared cannot be 0. What? We always take the denominator, and we set that not equal to 0. Every time. That's the domain restriction. Every time. Take the denominator, set it not equal to 0. Now take the square root of both sides, and x cannot be 0. That's my domain restriction. Okay.
I think
Now, you cannot put this into two binomials because it's x cubed. Since it's x cubed, you can't break down an x cubed evenly into two binomials.
Sorry.
So now, from left to right, 7x squared and 7x squared cancel out. What am I left with?
2x cubed plus 5x minus 3.
That's done, and this is what you need for both of them. Which is exactly what we did.
Yeah, but we did it complicated.
Well, I did it mathematically.
I
The business on me 7 or
Go to the next one.
I don't understand like
that one's already done.
We're going to do another one here in a minute. Guys, we're going to keep on doing it. We're doing the whole front page.
x cannot equal 4. That's all you
Can I factor x squared minus 6x plus 3?
Oh, it's perfect. It's fine.
No, because 3, there are only factors of 3 are 1 and 3. That's never going to give you 6, correct? Which means this is done. So my domain is going to be what?
Not equal 4.
X minus 4 cannot be 0, so x cannot be 4. The domain means that we're taking the denominator and setting it not equal to 0. Because we cannot divide by 0. So I want to know the numbers that whenever I plug them in for x, will make that denominator be 0. And 4 minus 4 gives me 0. Does that make sense? So that's why I'm excluding the number 4. Because if it's 4, then that makes my denominator equal 0. Can we understand that?
Yeah.
Number 3, can I factor this? There's no GCF because there's nothing in common between all 4 terms. And I can't put that into two binomials because there's nothing in common. So this thing is what? Done. So my domain. 2a plus 7 cannot be 0, so a cannot be negative 7 over 2. Number 4, 27n cubed plus 8 divided by 3n plus 2. This is the formula I talked about you guys using yesterday, the sum of cubes. And I said that a cubed plus b cubed was going to be equal to a plus b times a squared minus ab plus b squared. That's what I said, correct? And I said in order to use this formula, that a had to be a perfect cube. In other words, is 27 a perfect cube? In other words, what number multiplied by itself 3 times is 27?
3.
3. What letter multiplied by itself 3 times is n cubed? N. So A is going to be 3n in the formula, and B is going to be what?
2.
2. So I'm going to use my formula here, and I'm going to have a plus b. Well, what's a plus b?
3n plus 2.
A squared? Very carefully in your head, think about it. A squared.
3n squared.
9.
9n squared. 3n times 3n is 9n
Why would you
squared.
still need the square then?
Because
Because it's a squared. What's a? 3n.
Yeah. Well, I get that, but why would it be not that? Why do you think to?
Because the n is part of it. N times n is n squared.
Oh.
A times b. B squared. All over 3n plus 2. Now, when you use this formula, the second part of the formula becomes irreducible every time, which means I can't factor that any further. So I need to go ahead and do my domain restrictions. So my domain restrictions are going to be what here, folks? 3n plus 2 cannot be 0, so n cannot be negative 2/3.
That's all there is to it.
Now I need to cross cancel and reduce. Do I have 3n plus 2 anywhere? That's gone, that's gone. What am I left with? 9n squared minus 6n plus 4. It's a lot easier than what you thought it was on the front, is it not? Number 5. Can I factor that? No, since I cannot factor that, what do? I simply box it in because this thing is done. And what's my domain? 2x plus 1 cannot be 0, so x cannot be negative 1/2. Right? Negative 1/2. Yes? Turn it over. Number 8. How many of you did not like number 8 because there are 2 letters in it? Okay, well, what do you notice you have to do first with number 8?
Flip the second.
Flip the second fraction. So what you're actually going to have here is going to be 3a minus 3b over a squared plus 2ab plus b squared times a squared minus ab minus 2b squared all over a squared minus 3ab plus 2b squared. All I did was flip the second fraction and change the division and multiplication.
I still don't think Lance is in here. You'd be like, I don't know.
May I have your attention, please?
Now, I need to factor this into 2 binomials. So do I have a GCF here? 3. Pull a 3 out. I can see a minus b. I need to put this into 2 binomials, the denominator. So how do I put that into 2 binomials? A plus b times a plus b. Times, I need to do the second one into 2 binomials. How do I split up negative 2b squared to get negative ab in the middle? A plus, a minus, minus 2b, positive b. I'm just factoring. I have to break down a squared, so that's a and a. I need a negative, so my signs are opposite. I need to break down 2b squared. Factors 2 are 1 and 2, so I have to use b and I have to use 2b. It's a matter of where you're going to put them. I need a negative ab, so that goes with the bigger number. Remember? This or this? This one? Top one? They both have a 3 in them, so I divide each one by 3 by pulling it out. 3a divided by 3 is a. 3b divided by 3 is b. Okay, bottom, I need to factor again. So that's going to be a and a. I need to have a positive and a negative, so the signs are both minus. I need a 2b and a b to give me 2b squared. Everything is factored completely. Now, since there are 2 letters, are you listening? Since there are 2 letters in the denominator, I do not find the domain. Okay? I'm not going to ask you guys to find the domain with 2 letters. So the only thing we have to do now is cancel out. So do I have a 3 in the denominator anywhere? No. Do I have an a minus b?
No.
Yes. An a plus b? Yes. An a minus 2b? Yes. And what am I left with? 3 over a plus b. There's 2 plus 3 on that side. You just got that one. Yep. Tonight's homework. Are we listening? There's some problems on here that are duplicates from the last worksheet. I did not take them off for this specific reason. When you practice and redo a problem, you get better at that type of problem, correct? So I do not want you to cheat and just copy from your previous homework assignment. What I want you to do is attempt to do it by yourself, and whenever you're done doing that problem, then go ahead and check it. Number 5. Number 5. That looks really ugly, yes. Pi Day, March 14th. This looks really ugly, doesn't it? But you're going to take it one parenthesis at a time. So if you look at the very first parenthesis in the numerator, what do I find first? Always look for a GCF. So you pull out a 3. So that's going to give me 3 times x squared minus 16. Go to the second parenthesis in the numerator. Do I have a GCF? X. Pull it out. So that's x squared minus 3x minus 28. All over. Go to the bottom. Write down the x plus 4 2 times. Why am I writing that down 2 times?
That's squared.
Because it's squared, and you guys have a tendency to forget the exponents if you don't write it down twice. Do I have a GCF in the last parenthesis?
Yes.
X. So I pull out an x, and I'm left with x squared minus 11x plus 28. Now, I need to continue factoring the 2 binomials. So the jump is left. How do I factor x squared minus 16 into 2 binomials?
X
Minus 4.
4.
X plus 4, x minus 4. How do I factor x squared minus 3x minus 28 into 2 binomials?
X 7.
7.
4.
X what?
Plus 7. Minus 7.
X minus 7, x plus 4. All over. Bring down that jump. And now, how do I break down x squared minus 11x plus 28?
Minus 7 minus 4.
Oh, what? X minus 7, x minus 4. Now, how many letters do I have in the denominator?
1.
1. So can I do a domain restriction?
Yeah.
Yes. So my domain restriction will be what? Well, if this 3 not equaling 0, is that ever going to affect the problem? No, so toss it out. What about x plus 4?
X can't be negative 4.
Good. What about x plus 4? I already got it, right? What about x not equaling 0? I got to include it. What about x minus 7? What about x minus 4?
X cannot be 4.
So there's my domain restrictions. I took every single thing that was in the denominator and set it not equal to 0 and solved it in my head. So now I need to go from left to right. What do I do?
Cross that out.
Do I have a 3 in the denominator?
Yes.
Do I have an x plus 4? Do I have an x minus 4? Do I have an x? Yes. Do I have an x minus 7? Do I have an x plus 4?
Yeah.
And what am I left with? 1. Very good. The only class of the day who got it right the first time.
Seriously?
Yep, everybody else, half of them said 0, half of them said 1. Good job. Last one I'm going to do with you. Number 3.
Oh.
What do you think?
You take out 3K2.
Start by dropping the negative.
Get rid of the negative x on it. So make this a fraction. 9k cubed plus 12k squared hangs out, and minus 6k minus 8 goes to the bottom. Now, do I have a GCF in the top?
3K.
3k squared. And if I pull that out, 3k plus 4. The bottom, what's in common between negative 6k and negative 8? It's going to be a negative 2, so if I pull that out, I'm left with 3k plus 4. Now, how many letters do I have in my denominator? 1. Can I do domain restrictions? Yes. So what's my domain? -2 not equaling 0 does not matter, does it? So 3k plus 4 cannot be 0, so what does k not equal? -4/3. So now, from left to right, do I have a 3k squared in the denominator I can cancel out? No, I have a head to body attached together. So 3k plus 4 goes away. Then what am I left with? Okay, you guys know what's going to happen. Tomorrow when you come in here, I need both worksheets complete. I will let you quickly check your answers in class. And then we're going to have a short 3-question quiz to make sure that you guys understand what you're doing. All homework needs to be in to me tomorrow, which is worksheet 1 and worksheet 2. If it's not done, and I grade papers over the weekend, Monday whenever I come in, you'll be sent to the Ketchup Cafe for Tuesday and Wednesday. Any questions what I just said?
No.
Okay. A minute here.